All right, this is a long problem. Let's read carefully. A popular band starts making shirts and hats to sell at their concerts. On the first day of sales, 30 shirts and 25 hats were sold for a total of $650. On the second day of sales, 60 shirts and 45 hats were sold for a total of $1,230. Let X represent the cost of each shirt and Y represent the cost of each hat. Write a system of equations to model the scenario and solve that system to determine the cost of the hat. Okay, there's a lot of information here. What I'm going to do is I'm going to try to make the information just a little bit smaller for myself so I don't have to reread every time. Okay, so like this part, this says let X determine the cost of shirts. I'm going to just write X equals shirt, right? Y represent the cost of a hat. So I'm going to write Y equals hat. Okay, now what I notice is that here, like we don't have something starting at a certain place and then changing. That would be using slope-intercept form, Y equals mx plus b. But we have like two things being combined. So for that kind of situation, we use standard form. So like we're going to be using a number times x plus a number times y equals a number, that kind of equation. So it says, look, it's kind of like helping me along, right? It says first day of sales equation. So I'm going to go and I'm going to find, the first day of sales. Okay, 30 shirts and 25 hats were sold for a total of $650. So that means, okay, 30 shirts. So whatever the cost of the shirt was, like they made that 30 times, right? Like, so if a shirt costs $5 and they sold 30 shirts, I would do 30 times 5. So this is 30 times X. And then there's 25 hats sold. So whatever the cost of a hat was, that's Y, right? We're going to have that 25 times. And then we're going to add those together because it says there's a total of $650. Okay. All right, so now on the second day of sales, we're going to have a similar equation, right? This is 60 shirts, so now we have 60x plus 45y, right? There's 45 hats, and that total is 1230. Okay? All right, so now I have a system of equations, and look, I'm being asked for the cost of each hat, so I'm actually only looking for the y value. Okay, so sometimes I'll have to find both values. In this case, it's just asking me actually for the y value. So we'll see what happens. Okay, let's take a look at these equations. I have two equations in standard form, and I think to myself, okay, I need to use elimination. I need to eliminate one of these variables. And so I see, okay, like here, right, for example, 30 multiplies to 60, right? 25 doesn't multiply to 45. Like I would have to multiply both of these. But 30, if I just multiply 30 times 2, I get 60. So what I want is actually I'm going to take this top equation. So here's my equations, right? But I'm going to save myself work. I'm going to take this top equation and I'm going to multiply it times -2. Here's the reason I chose -2. 30 times -2 is -60. I want this number and this number to be opposites, okay? Or I want this number and this number to be opposites. It doesn't matter, but I noticed that this one's easier because 30 multiplies to 60. So I'm going to recopy this equation, except I'm going to multiply by -2. So -2 times 30 is -60. -2 times 25 is -50. And -2 times 650 is -1300. Okay, now this equation I'm just going to recopy. Why? Because look, I have a -60x here, and I want this to be a positive 60x right underneath it. Okay, now I can add these equations together, and look what happens. -60 plus 60 cancels. -50 plus 45. Look, there's more negatives than positives, but when I'm subtracting, I get 5. So this is 5y equals, and then 12, this is -1300 plus 1200. So there's more negatives, and the difference is 70. Now I'm going to solve. Y is being multiplied by -5. I'm going to divide by -5. Okay, I get y equals 14. Okay, now look, I only wanted y. So I'm done. It's $14. Now, if I wanted to be really cautious, like you would on the final, I would take this, I would plug it back into this equation and get an x value, and plug it back into this equation to get an x value. And if I get the same x value both times, that would tell me my answer is correct. So that would be the way to check it. I'm not going to check it right now. This is correct, but that would be the way to do it. Let me just, like on the final exam, for sure, I would go to the length of checking my answer, right? I would plug this in, solve for x, and I would plug this in and solve for x. And if I got the same x both times, that would tell me my answer is correct.